Yeah, welcome to today's class. Today we want to look at decimal number system. The last class, I gave you introduction into what? Number systems. And I gave you the different types of number system. I told you basically number system divided into two, non-positional number system and then positional number systems. So in the non-positional number system, I explained unary, which is what? Your tally, and Roman numeral. Now, this class, I am going to teach you decimal number system, which is actually a type of positional number system. So I told you, what does number system answer? The number of symbols that you use in representing number and how you combine these symbols to give you a number, right? Then I told you that the reason why we had to move into positional number system was because we needed to scale multiplication, division, and all that. So we needed to scale. So we had to have dominion, right? So we had to scale. And for us to be able to scale, science was able to discover what? This symbol. And that made the difference that we have this civilization today. So looking at decimal number system is what? Is giving us 10 digits, 10 symbols to work with. So, and those symbols are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. These are the symbols that we have in decimal number system. The discovery of this guy changed the whole thing, right? The discovery of it changed the whole thing. And in the last class, I told you, let us agree that this symbol is what? Female, right? And then let us agree that this symbol is male. Now, this symbol is not nothing. 0 doesn't mean nothing. Don't be deceived. 0 simply means placeholder. Placeholder. Right? Without this 0, no system in this civilization will survive. Everything will collapse. We will not have gotten the system that we are in or this civilization if this symbol wasn't existing. It's a placeholder, so it doesn't mean nothing. It's holding a space for something to come in. All right. So let's explain in decimal. So we count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If we are going to count 10, we don't have a symbol to represent it. Because in the decimal number system, we only have 10 symbols. And these 10 symbols is from 0 to what? To 9. So we don't have a symbol to represent 10. So if you are going to write 10, what do? We have to carry. So the only way we can carry and still maintain that structure is because of 0. If there was no 0, there is no way we could carry. So when we get to this point, that is 9. We want to represent 10. So we have to carry. So we'll now put 0 here and then carry 1 to this place. So the moment we do that, putting 0 here and carrying 1 to this place, this 1 and this 1 are not the same. So it means that the weight that this one is carrying and the weight that this one is carrying are not the same. This one is carrying the weight of 10, meaning 10 things. This one is just carrying a unit weight, just one. Why this one, this symbol, is carrying 10 things. So leaving this place as a placeholder. So without this one will have collapsed into this. So for this guy to sustain this structure, right, we need to have this guy placed here. So you see, now if you look at this pattern, it means you've gone a complete cycle like this, We started from here and we have come back to it. So it means we've come back to what? To the very place where we started our journey. I hope you are seeing what I'm showing you. So if we have a number like this, 3, 4, 5, these are symbols. This is 3 is a symbol. This is 4 is a symbol. This is 5 is a symbol. How then can we derive meaning from this to now call this 345? How did we arrive at that? It is based on what? The base. So in order for us to extract this number from this symbol, we have a formula which states that value equals to sum of, right? We can put it in bracket if we want, like this. Digit, right? Multiply by base, position, raised power position. So this is the formula. Sum digit multiplied by base raised power position. This is position 0. And since we are looking at decimal, it means it is what? Base 10. So to extract this number from this symbol will now be digit, which is 3, multiplied by what? 10. Plus, that is why you're having this sum. 4, multiplied by what? 10. Plus 5, multiplied by what? 10. Now, this 10 is the base. The digit are those things. But we have the base raised power position. So that gave birth to something we call zero exponent. If humanity or scientists have not discovered zero, it would have been impossible to have this. So zero exponent, meaning that we are starting this one from what? Position what? 0. Meaning this is starting from position 0, from the right-hand side. This will be what? Position 1. And this will be what? Position 2. So it therefore means that this is what? 3 times 100. That is 10 times 10, 100. Plus 4 times 10. Plus 5 times. Now, any number raised to power 0 is what? 1. That is another thing I have to explain to you, which is what? The zero exponent. How did we arrive at agreeing that any number raised to power 0, meaning a raised to power 0 equals to what? 1, except 0 raised to power 0. That one, undefined. But any number, any digit, or anything other than 0 raised to power 0 equals to what? 1. If you look at the pattern from this 0 and you are going this way, this is 0, right? 10 raised to power 0, 10 raised to power 1, 10 raised to power 2. It means, let me write it out like this. So we are having 10 raised to power 2, 10 raised to power 1, 10 raised to power 0. In coming this way, you are increasing the power. But in going to the right, you are reducing the power. So this one is the same thing as this. This is 100, right? So this one is the same thing as 10. That is 100 divided by 10. That will give us what? 10. This one is the same thing as if you follow that pattern, this one will be the same thing as 10 divided by 10. And 10 divided by 10 is what? 10 raised power 1 divided by what? 10 raised power 1. So this is division. Then for the rule to be correct, we now say 10 raised power 1 multiply, if you are changing this to multiplication, 10 raised power what? Minus 1. Then we agreed that 10 raised power 1, if the base are the same, this one will become plus. So plus minus 1, which it gives us 10 raised power 1 minus 1, which is what? 10 raised power what? 0. Right? And you know that 10 divided by 10 equals to what? 1. That is how this 10 raised power 0 is giving us 5 times this. What then is this telling us? It is telling us that if we raise any number other than 0 to what? To 0, it will give us 1. Meaning the anchor point. It therefore means that 5, this 5, it therefore means that the anchor point is what? 1, which is what? The foundation, the starting point. And everything that we are going to measure will be in reference to what? To that anchor point, which is that 1. So it means that this 5 is 5 units of the reference point, which means 5 units of what? Of 1. This 4 is what? 40 units of the reference point. Why this 3 is 300 units of the reference point. So if we did not discover this 0, there is no way we will have been able to determine what? The anchor point, which is the starting point, which is what? 1. So you see, 0, 1 is a paradox. The chicken and the egg, which one came first? Is it this one or this one? Is it the male or the female? Which one came first? I have explained this to you before, that there is, when you are coming from above and when you are going from below, that is when you have to view which one is actually first. Right? So, to now derive the number from this symbol, so you are having 10, that is 100 in 3 places, which means 300, right? And 45, that is 45. So that is how you were taught in primary, where you were told that it is what? Unit, right? Tens, 100, right? Then you keep going, 1,000 like that. And then you have this one on this side. That would be a different class. So you keep going like that. Unit, tens, 100, then 1,000 like that. You keep going. But this is the equation to derive it. So the value, which is what? 345, right? Which is this value, is actually gotten from what? This equation. And this is how you are actually operating using this base to be able to get this value out. Even if you use binary, that is binary, which is what? Base 2, right? This equation still stands. And this position and base is the same thing. Will still give you the same output. So I'm only using this class to teach you decimal. The next class, I'll teach you binary, and you will see that it is the same concept. So the 0 exponent, right, will give you 1 as the anchor point, which means the very foundation of the structure. So this one tells you the beginning of any structure. Why this one, which is this 0, holds the structure together. So both of them work hand in hand. So if you have something like 101, you can see that we're having 0 in it. That is 101. If this one was not there, this will collapse into 11. It means that this structure cannot hold. So it is a placeholder, and it also helps to define the starting point of your measurement. It's very key. So 0 and 1 are just symbols, or 3, 4, 5, they are symbols. But how are you able to extract the value that is in this symbol? You are only able to do it because of what? What I've just explained. First, by looking at the base is very important. 2, the starting point, which is the anchor point, and that is determined by what? The 0 exponent, meaning the power of the base to that position. So that is what I want to show you in this decimal number system. The next class would be, so with this, we can multiply. If we multiply, all we just need to do is find this base and the position, and we'll be able to scale. So this could work. The next class, I'll teach you binary. And that is because of what? The state of the machine. That is why we still had to what? Discover binary. But already, by discovering 0, and then from this 0, we're able to extract the anchor point, and then based on that, we could build and we could scale. So, till we see in the next class on binary. Bye-bye.